Hi, I'm Syed Bilal Rizwan, and this is Mohammad Salman Khan. We would like to present our deep learning project on variational autoencoder. So the motivation behind the project is that when we do machine learning, we face datasets that are highly imbalanced. By imbalance, we mean that some of the positive classes are very low compared to the negative classes. So when we train the model is able to predict the negative classes better than the positive classes. Sometimes we actually want to predict the positive classes, but the model is not able to do so because of the imbalanceness. So to combat that, we have several techniques such as SMOTE and Gaussian mixture models, but we would like to present a new technique which is variational autoencoder to make artificial samples and balance our dataset and see how the machine learning works then. So to do that, we actually used it on three different datasets such as credit card fraud, marketing, and heart disease datasets. All three of them are highly imbalanced datasets where credit card is the most imbalanced with 0.172% of positive classes only. So let me give you a little bit of background about it, like how a variational autoencoder works. A variational autoencoder is a generative model compared to the other variational or compared to the other autoencoders, such as denoising or vanilla autoencoder. The initially when autoencoders were created, they were used for dimensionality reduction techniques, but this is a new type of autoencoder that is used for generation of data. So how does it work? So when it has a encoder and a decoder layer, but the main difference between a normal autoencoder and a variational autoencoder is the loss function. The loss function in the variational autoencoder contains a KL divergence term that ensures that code, the latent space in the AVA model actually only learns the density of the data rather than the data itself. So that ensures that you are able to sample from the density later on whenever you want to and how many samples as you want to. Similarly, let's talk about the other techniques like SMOTE. SMOTE is actually a balancing techniques that use k-nearest neighbors to balance the dataset. Similarly, Gaussian mixture models actually learn the entire joint density of the data and sample from it. So then we used vanilla autoencoder as well, which is used just for experimentation. And it is basically a dimensionality reduction model. However, we used it as a generative model to see how it works. So now I would like to give it to Mohammad Salman to actually go through the methodology.
Okay, so the methodology that has been used throughout this experiment is given here. We started by loading the dataset, then training and testing machine learning models on that imbalanced dataset. Then variational autoencoder and other balancing techniques like SMOTE, GMM were utilized to balance the dataset, and then the same machine learning models were again trained and tested on those different balanced datasets, and they were compared with each other by the evaluation metrics like accuracy, recall, precision, and F1 score. The implementation starts by loading the libraries, and then the credit card fraud dataset was first loaded. Uh, it was pre-processed, scaled, and then machine learning models were trained and tested on it. So these were the performances by the original dataset. After that, variational autoencoder was used. We will be sharing this code with you by the link in the description. So this is the code to generate records to balance the dataset. After balancing, machine learning models were trained and tested, and these were the performances after balancing to variational autoencoder. We can see that these performances are in a close range, and each model has done similarly well for this particular balanced dataset. For the SMOTE, when the models were trained, we can see that some models have done better than others, while the performance of some models were very bad, like logistic regression in that case. After after this, GMM was utilized and models were trained and tested on the balanced dataset uh, that was given by it. So again, we don't see very good performance of machine learning models here. and also different models have done differently in terms of the performance. So this is, after that, vanilla autoencoder is used. Vanilla autoencoder is not a balancing technique. It just takes input and reconstruct it into an output. So it did not balance the dataset, and it has just mimicked the performance of the original dataset. As we can see here, the original dataset was equal in the performance when we compare it to the vanilla autoencoder. So this is the implementation and methodology. Now we will be going towards the analysis that we have done from this. Here we have the performances of different models on different modes of datasets and a little summary of it. In this experiment we found that while variational autoencoder generated balanced datasets resulted in consistent and similar performances across all the models here. But we do not see any significant difference when we compare it to the original dataset that was imbalanced. And we also see that SMOTE and Gaussian mixture model generated balanced dataset have not done very well when we compare it to the variational autoencoder generated dataset and the original dataset. We repeated the process and compared the original imbalanced dataset performance and the variational autoencoder generated balanced datasets performance for marketing data and the heart disease dataset. And here we can see the differences, how they have done. We do not see very big improvement in the overall performances when we balanced the data set using the variational autoencoder. These results suggest that while variational autoencoders can be a very effective tool for generating synthetic samples for balancing and out of balance data sets, they may not necessarily result in a large improvement in the model performance for every case. We can do further research to conclude that whether variational autoencoders can be tuned in a way that they can be used for balancing techniques. But this was our experiment with the variational autoencoder that we have used. I hope that it is and has been informative for you. Thank you so much.